Hi, Dr. Toddy. So this is hand tutorial 6. I think we just needed to do you need to do a video for this, and then we need to do a reflection video, I think, too. So going over this, I found, oh, yep, okay, you can see it over here, and I hope the mic volume is better. I turned it up, so hopefully I'm not like a mouse whispering to you. I found this sklearn documentation. It has examples for cross-validation, and I essentially just implemented what they had. I already had, and I'm working off the homework 5. You mentioned working off hands-on tutorial before. I figured I liked how I had things set up in the homework, so I just kind of built off that. I kind of wanted to improve. I wanted to improve the decision tree, because out of the 3 models from the homework, homework 5 to be exact, decision tree was one I was most interested in trying to improve. So that's what I worked on for the GridSearch, and then I did the evaluation with for that decision tree as well. So originally I did a max depth of 6. You can see that good. And so following this, I have the source here too. We have right here, cross-validation score. Where does it do this at? Right here. So doing this here, essentially with the kind of same model I did above, up in section 4.2, where right here. So this same model that I found with this graph, I found that 6 was the best depth out of this. So I took this model here, and down in who knows what land right here, I remade that model, and I did the cross-validation score with a cross-folded 10. I think from the Stats Quest video, I think I mentioned cross-fold 5, cross-fold 10. So I wanted to try the cross-fold 10. That's what I did for each of them. So I did this one originally. So I did this first one. It had the crossfold 10 and crossfold 7 had a 1% increase in accuracy. As I right here I have the original 84. So we had some big, well, not big, but like negative 3% versus a positive 1 uptake, which is not really that big of a difference when we're looking at the evaluation. So to me, that just tells me that really there's nothing in the data that really defines what makes the model, if it's in the training set or in the test set. There's not one big section that really influences the model. Just to further validate that, it mentioned the shuffle split. You can see it right here, good. The shuffle split, it did really nothing. It kind of kept the results the same, minus a couple points, very few. So nothing really telling here. So moving on to the GridSearch. Oh, and I was curious if I needed to refit the model to validate it, and I found this Stack Overflow thing where someone's like, do I need to fit it? And this guy right here said, it's called fitting the model is done inside the cross-validation score. You don't need to worry about doing it beforehand. So I figured that would be cool, something I can include for you in case you were wondering, because I was wondering. On the GridSearch, originally I opened up the documentation. I wasn't seeing anything that like really was giving me hard examples. Like we have the param here. Like I can read all this if I need to. Down here there's this example, but I wanted something that was specific for decision tree. So I found this article here. Some guy posted. He seems pretty credible if you look at him. Amit Yad. This guy right here, he seems like a very credible man. So he's done a couple articles. So I followed what he went through for creating this for GridSearch. You can see I copied that right there. It's still highlighted. he defines his model already, and then he sets up this grid parameter, and he explains what each one kind of means. Where does he do that? Step by step. So I technically took some of what he said, rewrote it a little bit. Some of it I didn't really write. But the max depth, we already know that. We already used that before. Is just how deep the model goes. The mid sample split. Sets the limit for when a tree is allowed to keep splitting. So I just put 2. I think what did he have? He gave me a list of these 5. He told me about this one, this one, this one, this one, this one. But when he did his model, he only did max depth, mid sample split, and the criterion. He didn't include the sample's leaf or max features, so I just randomly guessed what to do for those ones. For his max depth, he did 3, 5, and 10. I knew from before that my perfect max depth was 6, so I did a 3, 6, 9, 12. Knowing that for me, I think 6 is the best, so I kind of did base of 3. So the min sample split, he did 2, 5, 10. I left that the same. And then the criterion, I left the same because he only covered those 2 criterions. I didn't know there was any more. I didn't really go back to the documentation after opening his article. The mid sample leaf, I just guessed. So that's the minimum number of samples that should be in each leaf node. I think the data set itself has 40,000 records. So I kind of just went, just slowly increased it until we got to 5,000. And then the max features themselves, that's how many can be, that's the max number before it should split off. I did kind of just slowly increasing it all the way up to 22,000 because, again, we have 40,000, so I wanted to see what a big number like that would do. And then I made my grid search scoring accuracy. That's what he was going off of over here. A cross-fold of 5 he set, and the best hyperparameters it got was a max of 12. Now that kind of surprised me because if we go back up to section 4.2, we're seeing a slight decrease here. I never hit 12, but I would not expect this to spike back up. So something happened where 6 was below 12 at some point for these parameters. Where are we at here? So this combo here made 12 actually stand out the most. And the max features, the mid sample leafs, are pretty low, so me going pretty far down this list here really didn't do anything for me. And it found that the criterion is Genie. So I saw this accuracy of 84, no improvements, and I'm like, I don't want to stop there. I want to just try to improve it somehow. So I came over to my good old friend ChatGPT, and the link is here for this chat. You can go through it. I gave it the original validation, and then I gave it the new results, and I said, wasn't much improvement. Should I run another grid search? It told me what about that, and it told me that I should really try to focus on predicting if they're out of bikes. That's the goal of this model. We want to predict 1. We don't want to be good at predicting 0 because we already know if they're going to have bikes. We want to know what day it's going to have no bikes, so we can maybe get more or something along those lines in a business perspective. So it told me some things to try to improve. It said to focus on recall. So it gave me this cross-validation stratified k-fold. So I added that in here. And then it wanted to use class weighting, which is this class weight thing here. So it gave me the original 5. It gave me 1 extra criterion log loss. I have comments here explaining each of the thing and why, so you don't have to read through the chat yourself. It's there in a comment if you want to. But it puts pressure on producing better calibration for class probabilities. And then it gave me some things I didn't know from the original article, like you can put square root or log 2 in here. And then 2 more parameters for grid search, which is class weight, like it discussed, which is going to put more. It's going to increase recall because it's going to penalize it making wrong predictions for class, like predicting 1. And then this CCP alpha, as the tree grows, it can prune off anything that overfits or gets noisy. So running this model, we're gonna we're gonna focus on F1 instead of accuracy, and this just means use all cores. This took an hour for me to run the fit, 55 minutes. I went and made lunch. So if you're already running my work, I don't know how long that's gonna take for you. So I'm sorry but it works. There's no errors, so don't worry. And the best parameters, so we got a CCP alpha 001, so I don't think there's any overfitting happening. I mean, there's a big in-class imbalance, so the only overfitting was in the random forest, so I would expect in the random forest for this to be higher. The class weight, so we did apply more weight for predicting 1, and it came with the criterion and entropy. I can't speak. And a max depth of 9 this time. So in between that original 6 and the prior grid search of 12, and it went with no max features. So to really test it out, it gave me this printout, but I had my original validate model, and I didn't feel like deleting this and having to rerun the notebook for you. So I left that in there so I didn't have to rerun and sit there for another hour. One more thing. Having refit equals true makes it, after it finds the best parameter, it will retrain the model and keep that best model for you with those parameters. So using that best model, you can get it like this. I reran my validation and got an accuracy of 83, so just -1 for those two. And going back down, we want to look at this, our precision, recall, and F1 score. This is down slightly, but our recall is up 18%. So really what this means, and I of course asked our little assistant over here what that means. It means that it's going to have more false positives than false negatives. So instead of not predicting when a place runs out of bikes less, it's going to just over predict. So it's going to be like, well, this is cloudy, or it's a bright sunny day, everyone wants to ride a bike, let's just say that they're going to be out of bikes that day, versus no. There is still a big class imbalance issue, so that's just still there. So I would still not use this model for a business perspective to make any kind of business decisions. I think I ended it off with we still need more data for when places run out of bikes. I don't really know what this place is called. I'm assuming it's a bike rental shop. So when they're out of bikes, they should really keep more record of it. But maybe a couple more years of recording data, they'll have a nice data set for this. So that's what I did. That's my hands-on tutorial 6. So thank you, Dr. Toddy. Sorry, that was a lot of rambling. 14 minutes. Wow. Sorry. 2 times speed.